Hey, so let's begin by analyzing the problem. And it told us that the population of a country has been decreasing for several decades. We know that decreasing means going down. In 1990, the population was 181 million, and then in 2010, the population was about 172 million. Determine the percent decrease in the country's population during this time. So this is what we call a percent change problem. And you use this kind of procedure whenever you have an original amount and then that amount increases or decreases. And you want to find out what percent it went up or down. And whether it's increasing or decreasing, the procedure is really the same. You just have to keep the direction of the change. So whether it's going up or down, you just have to keep that in mind. So the first step is to calculate how much it changed. So you are going to take the most recent amount, so the one that occurred last, and subtract the original amount. So remember, original is another word for first. So if we look up here at our problem, the most recent one is, of course, that 2010. That's the latest amount. So the population at that point was 172 million. And because both of these populations are listed in millions, I am actually not going to go and add the extra zeros that I normally would to do a problem, because since they're both in millions, I'm going to end up with the correct answer without doing that. So then I'm going to subtract the original amount. So what was it first? In this case, it was 181 million. So if I subtract 172 minus 181, I end up with -9. And it makes sense that I end up with a negative number because a decrease coincides with a negative. So it makes sense that we got a negative number. Step 2. And I'm going to kind of make step 2 into two shorter steps that kind of make up that big step together. I'll show you what I mean. So in one big step, so in my calculator, I'm going to tell you about two calculations, but I'm going to do them all together because it's going to save me trouble rounding. Okay, so I'm going to divide, first of all, so I'm going to call this step A. I'm going to divide the change by the original amount, and then step 2 is then to multiply by 100. So it's kind of like this is step A, dividing. Step B is then multiply that by 100. I'm going to take these two smaller steps and combine them into one big step. And you'll see why that makes sense to do that in a second. So my change was, of course, that -9 we got in the previous step. It went down by 9. The original amount, so what it started, was 181. So we're going to divide -9 by 181. Then we're going to multiply by 100. So I'm going to type in my calculator -9 divided by 81, and then I'm going to multiply that by 100. And the reason I'm doing it all in one step, and you can go ahead and take a look at this if you want. If I do -9 divided by 181, and you can do that with me so that you can see for yourself as well, you'll end up getting a decimal that doesn't repeat, doesn't have a pattern. It just keeps going and going and going, like 0.04972337. And I know rounding can be confusing for people. So instead of deciding how to round that division problem and then going back and multiplying that answer by 100, because you have to multiply it by 100 because that 0.9 is going to get you a decimal, right? But the problem is asking you for a percent for your final answer because it's asking for a percent change. So if you go ahead and multiply that decimal by 100, remember to turn a decimal into a percent. You take the decimal and you move it 2 places to the right to turn it into a percent. Well, taking that decimal and multiplying it by 100 accomplishes the same thing. And that way I don't have to worry about how to round that decimal. So in my calculator, I just did -9 divided by 181, and then I multiplied by 100, and I got 4.97237, and a bunch of other stuff. I could keep going on and on and on, which is why I'm writing the dot, dot, dot right there. Okay, because it could really go on and on and on. So how do I decide how to round? And by the way, this is a percent we're talking about, because again, I took that decimal from the previous step, went ahead and multiplied it by 100, so that converted that decimal into a percent. So how do I figure out how to round this crazy percent? So you got to read the directions. The directions to the problem told us to round to 1 decimal place. So 1 decimal place is right here. So we're going to decide, are we going to round this to either 4.9, like are we going to keep that 9 the same, or are we going to round that 9 up? And remember, the rule for deciding that is that you look at the number to the right. And if it's 5 or bigger, then you round up. In this case, 7 is obviously bigger than 5. So that means that it's going to result in rounding that 9 up. Now, if this were any number besides 9, we would simply round that 9 up to the next highest digit and call it a day. But of course, when we round up that 9, that's going to end up rounding it up to 10. So that is going to have the net effect of also rounding up that whole number as well. And again, this is only because that one decimal place, which is where the directions told us to round, happens to be a 9, and we have to round up because that 7 is bigger than a 5. So that's why we have to round it up. So because that 7 tells us we're going to round up the 9, that 9 is going to round up to 0, which is going to round that 4 up to a 5. So my final answer, if I round it to the nearest decimal place, is 5.0. And I'm going to use my little squiggly equal to sign because this is an estimation. So, oh, you know what I forgot to do? I almost made a very common mistake. Okay, this is a negative number. So that decrease, that's actually a negative 4.9, which means it's going to be a negative 5.0%. I'll show you another example for the rounding just to make sure we're on the same page. So let's say I did all these steps. I calculated my change. I divided my change by my original, and then I multiplied that number by 100. And I ended up with the decimal 6.352 and a bunch of other decimals there at the end. So again, rounding to 1 decimal place, I'm going to round that 3. I'm going to look to the right, and I'm going to see that that number is 5 or bigger, which means that I'm going to round that number up. So my final answer is going to be 6.4%. If I had, let's say I did all the steps and I had 3.2375 ... percent, because again I got a big ol' decimal there at the end, I am again following the directions and rounding to 1 decimal place. But I look to the right this time, and 3 is smaller than 5. So that means the 2 is not going to round up. It's just going to stay at a 2. So then my answer would be approximately 3.2%.